Hello everyone, welcome to helpmate.com. So this time we graph the rational function. Okay, so please look at the given gx. So gx equal to 1 over 6 minus x, right? Okay, and based on that, we can determine the vertical asymptote and the horizontal asymptote. So as you see, the degree of numerator, which represent x to the 0 power. So you know that x to the 0 power is always equal to 1, right? Now, denominator equal to 1. So, 1 is bigger than 0, so we can say y equal to 0 become our horizontal asymptote. Now, the vertical asymptote, so this one here, so 6 minus x cannot be 0, which means x cannot be 6, right? So x equal to 6 become our vertical asymptote. Make sense to you? Okay. And now, because we have y equals 0, y equals 0 means x axis, right? So that's our horizontal asymptote. So we cannot find the y-intercept. Okay? But what about x-intercept. But what about y-intercept? So we plug z0, which means 1 over 6 minus 0 become 1 over 6. That will be our y-intercept. Okay, then let's draw the graph based on this. So 1, 2, 3, 4, 5, 6. So I'm gonna just set up the horizontal asymptote as a blue color here. And then vertical asymptote, orange color. So 1, 2, 3, 4, 5, 6, right here. Okay, now I also indicate y-intercept, which is 1 over 6. So 1 over 6 is around here. So something like that. Okay, so the last time we talked about y equal to 1 over x graph looks like this, right? Okay, and now what about we just make a y equal to negative 1 over x? Because of the negative here, we can rewrite this 1 over negative x. So x must be opposite. Okay? So which means increasing so far this is the positive x, but this case it must be negative x, turn into negative x. And then now decreasing was negative x here, right? But this time it turned into positive x basically. So this lower graph go to here and then upper graph go to here. So negative 1 over x graph looks like this basically. Okay, based on this theory. Now it shows that vertical asymptote is x equal to 6. So we just make this graph based on x equal to 6. So graph becomes looks like this, and then now we pass through y-intercept and then moving like this. Okay, so that's the graph of this function basically. Okay, then look at one more example. So gx equal to 3x squared minus 8x plus 4 over 2x squared minus 3x minus 2. Okay, so this one require factoring basically. So I'm gonna factoring and then see whether we can simplify a little bit. Okay, so first of all, 3x squared minus 8x plus 4. Moving this one here, then become x squared minus 8x plus 12. Don't forget we have a equal to 3 and 12, negative 8. Those two numbers are negative 6 and negative 2, right? So x minus 6 over 3, x minus 2 over 3. Okay, so this become x minus 2 times 3x minus 2. And now the denominator 1. So 2x squared minus 3x minus 2 going here. Then x squared minus 3x minus 4. So don't forget a equals 2. And this becomes negative 4, negative 3, which means negative 4 and the positive 1. So x minus 4 over 2, and then x plus 1 over 2. So x minus 2, and then 2x plus 1. Okay. So we can rewrite this function as a factoring form. X minus 2 times 3x minus 2 over x minus 2 over 2x plus 1, basically. Make sense to you? Good. Okay. And now those two canceled out. So now we can define x equal to is the removable undefined value. Okay. So now we can rewrite gx equal to 3x minus 2 over 2x plus 1. Okay. So based on that, we can determine horizontal asymptote and vertical asymptote. Also, let's find out x and y intercept. Okay, so now look at their degree. So this is 1, they're also 1, which means they have exactly same power between numerator, leading term of numerator and the leading term of denominator. Therefore, this case, y equal to their coefficient, which is 3 over 2. That's our horizontal asymptote. Okay. Now the vertical asymptote, which means the bottom becomes 0. So I set up 2x plus 1 equal to 0, then minus 1, so that 2x equal to negative 1 divided by 2. So x equal to negative 1 over 2. That will be our vertical asymptote. Okay? Vertical asymptote. Okay, so based on that, let's find out the y-intercept. So y-intercept means when x equal to 0. So we can utilizing this simplified function. So g0 means 3 times 0 minus 2 over 2 times 0 plus 1. Therefore, negative 2. So 0 comma negative 2, that will be our y-intercept. X-intercept means y equal to 0. So which means we only think about the numerator. Okay? Why? Denominator cannot be 0. That was the reason. So just making 3x minus 2 equal to 0. Then plus 2. So 3x equals 2. And divide by 3. So that x equal to 2 over 3. So 2 third comma 0 can be our x-intercept basically. Okay? Now, because we have the variable terms on the top and the on denominator, numerator and denominator, I will select few value to find and then draw the graph. Okay, so basically, we have only one vertical asymptote, which means the graph will divide two different sections. Okay, through t-chart. I'm gonna make maybe, so right side maybe 0 and 1. I guess that may be enough. The left side negative 1, negative 2. It is all centering on x equal negative 1 over 2. Okay, so based on this, I found two values on the right side and two values on the left side. Okay. Then if you plug 1 here, so g 1 equal to 3 times 1 minus 2 over 2 times 1 plus 1. So 3 minus 2 over 2 plus 1. So 1 over 3. 0, we know 0 already, which is negative 2. Now negative 1. So 3 times negative 1 minus 2 over 2 times negative 1 plus 1. So negative 3 minus 2 over negative 2 plus 1. Therefore, negative 5 minus 1 becomes 5. And g negative 2 becomes 3 times negative 2 minus 2 over 2 times negative 2 plus 1. So negative 6 minus 2 over negative 4 plus 1. So negative 8 over negative 3, which means about 8 over 3. Okay? All right, then let's draw the graph. Okay. So 1, 2, 3, 4. First of all, the horizontal asymptote, which is 3 over 2. Okay. So 3 over 2, which is 1 to 1.5. So it's around here. Now the vertical asymptote is negative 1 over 2. So right here. Okay. So as you see, based on the vertical and the horizontal, it divides two different sections. And now I indicate the given value. So 2/3 and 0. 2/3. So right here. And then 0 and negative 2 right here. And known value negative 2 and 8 over 3, which is about 1.2 here. So around here. And negative 1 and 5 over here. Okay. So based on this, I can draw the graph. One is going like that. And the other one going this way. Okay. So there will be graph of this function basically. Okay. So today we mainly talk about graph of the rational function. So one we kind of covered simpler one, the other one a little bit more complicated one. So I hope this video help you how to graph the rational function. Okay, then I'm gonna see you with a different video next time. All right, bye.